A simplified way to evaluate high-speed switching circuits. A chapter on scientific measurement and data processing. What you can measure and how accurately, and what to do with data. Bandwidth narrowing methods are made clear. Signal averaging, multi-channel scaling, lock-in amplifiers, and pulse height analysis. Amusing collections of bad circuits and collections of circuit IDs. Useful appendixes on how to draw schematic diagrams, IC generic types, LC filter design, resistor values, oscilloscopes, mathematics review, and others. Tables of diodes, transistors, FETs, op-amps, comparators, regulators, voltage references, microprocessors, and other devices. Generally listing the characteristics of both the most popular and the best types. Throughout, we have adopted the philosophy of naming names, often comparing the characteristics of competing devices for use in any circuit, and the advantages of alternative circuit configurations. Example circuits are drawn with real device types, not black boxes. The overall intent is to bring the reader to the point of understanding clearly the choices one makes in designing a circuit, how to choose circuit configurations, device types, and parse values. The use of largely non-mathematical circuit design techniques does not result in circuits that cut corners or compromise performance or reliability. On the contrary, such techniques enhance one's understanding of the real choices and compromises faced in engineering a circuit and represent the best approach to good circuit design.